Alright, so today's integral looks a bit scary, but it's actually not too bad. I'm going to show you how it works. So it's the integral from 0 to infinity of 1 over quantity x plus 1 over x squared. So first what we're going to do is use our first formula up there to expand the denominator. So we'll still have integral from 0 to infinity, but it will be 1 over x squared plus 2 plus 1 over x squared dx. Now what we want to do is we're going to multiply numerator and denominator by x squared. That's just the same as multiplying by 1, but it will get rid of all the fractions inside fractions nonsense, and it will make it easier to work with. So doing that, it will be x squared over x to the fourth plus 2x squared plus 1. We are now going to factor the denominator using our first formula again, just in reverse, just returning it back to its perfect square form, but it's easier to see things. So it will be x squared over x squared plus 1, quantity squared. And it's in this case that we are going to do a trig substitution. We are going to let x equal tangent theta, and then dx would equal secant squared theta, d theta. Plugging this in, we'll first have to do our bounds change. So tangent of infinity is pi over 2, and tangent of 0 is just 0. Now if we plug in the values, we will have tangent squared theta, secant squared theta in the numerator. The denominator, we will have tangent squared theta plus 1, but based off this formula, that's the same as secant squared theta. So this part will be secant squared theta, but it's all squared. So all in all, it will be secant to the fourth theta in the denominator. And that actually is nice because it could cancel a little bit. Numerator has secant squared, so that's all gone. And if we cancel a secant squared in the bottom, that will turn the secant to the fourth into just a secant squared. Now we're going to move up here with more space. And what we're going to do is turn it all into sines and cosines. So still integral from 0 to pi over 2, but it will be sine squared x, or sine squared theta, I should say. Sine squared theta over cosine squared theta, all over 1 over cosine squared theta. All written, all with d theta, whatever. Now this 1 over cosine squared theta and the numerator and denominator all cancel, so we will just be left with the integral from 0 to pi over 2 of sine squared theta. And this actually isn't terrible to integrate. We have a formula right here. Sine squared of variable, in our case theta, equals 1/2 minus 1/2 cosine 2 theta. So let's rewrite our integral as that. So integral from 0 to pi over 2 of 1/2 minus 1/2 cosine of 2 theta, d theta. And now we can just integrate this as it is. The first term will be 1/2 theta. And the next term, let's just do a u substitution in our head. It would basically just end up being 1/4, and then this cosine 2 theta would end up being a sine 2 theta. From there, it's evaluated from pi over 2 to 0. Plug in pi over 2 here, that will be pi over 4. Plug in pi over 2 here, that's just going to be 0. So this is our first part, and then minus, plug in 0 here, it's 0. 0 here, it's also 0. So our whole answer, because all of these zeros, it's just going to be pi over 4. So something as scary as that simplifies down just to pi over 4.